Okay, so this is January 2019 paper. Question number one says define the term mass number. It's the repeated question. I think so. We have also discussed this question in the last paper. Mass number is nothing but sum of it's the sum of proton and neutron, isn't it? It's
Hmm.
the sum of proton and neutron.
Okay.
Then relative mass of neutron. Relative mass of neutron. Of course, the relative mass of neutron is 1. And also the relative charge of neutron is 0. And then I can write down 1. I can write down 0. I can write down 1 over 1840. And this is going to be negative 1. The relative charge on the relative charge on electron. The relative charge on electron, right?
Right.
Okay, then predict whether the atomic radius of calcium is larger than, smaller than, or the same as the atomic radius of calcium 42. Then your answer.
The I think it would be the same because the neutron number does not matter. Like it doesn't change anything.
Yes, basically it would be the same. Basically it would be the same because atomic radius is related to the number of electron. Atomic
Yeah.
radius is related to the number of electron and proton, right? So in both, they are isotopes of each other. In both, the number of electrons and protons are same. They are
Right.
isotopes of each other. So they have same number of electrons. Okay, this is easy question. This is easy question. How you will do this question?
Um. I just 1 second. So I think we'll add 96.8 and 0.19. Subtract that from 100 and like do
Okay.
40 times 96.80 plus 42 times 0.19, and then x times what I just said, like 96.8 times 96.8 plus 0.19, subtract that from 100. So, and then you'll divide all of that by 100 and multiply that by uh divide all of that by 100 and equal it to 40.12.
Yes, they have given you the relative atomic mass of calcium, that is 40.12 is equal to relative abundance of the third isotope. Determine the relative abundance of the third calcium isotope. The sample of calcium has a relative. Use your answer and the data in the table to determine the mass number of the third. Okay. So it's 40 times 80, 96.80 plus 42 times 0.19 plus 100 minus 100 minus 96.80 plus 0.19 times x, I can say, isn't it? Divided by 100.
Okay. Yeah.
Okay. Oh, yeah, this question.
Yeah, like that.
1.5.
Okay. So we'll take like the MR, mass number, multiply by Avogadro's constant to get it in grams, and then divide that by 1,000 to get it in kilograms. So 42 times 6.02 times 10 to the power of 23,
42 times what?
and divide that by 42
42
times
times.
6.02 times 10 to the power of 23, and divide
Okay.
all of that by 1,000
To
to
convert it
give you
in
the answer.
grams, right?
No, to convert it into kilograms.
Kilograms. Yes, we would be getting the answer in grams basically. So they are asking in kilograms, so we have to convert it in kilograms. So we are going from the smaller unit to the larger unit, so that's why we are going to divide it. Okay. Okay, okay, okay. Again, the same question. Again, the same repeated question that we are continuously looking at this question since 2 to 3 papers.
Yeah.
Okay. So what they are asking in this question, they are saying use the equation to calculate the length in meter of the flight tube. So they are asking about the length in meter, like the distance.
Hmm.
So for this one, you need to know V. For this one, you need to know V. They have given you the formula for V. They have given
Right.
you the
So I
formula
think
for V.
instead of doing like half mv square, we can just do half m d over t square. We can do
Yeah,
that.
exactly. Directly
And
you can put yes.
okay, so kinetic energy is already given, half, and then do we have the mass? Um. Okay, we found the mass in the previous question. So we have mass, we have kinetic energy, and as for the velocity, we need the length. Okay. So we have the time, and then the distance we can find. So I'll make this. I'll make D the subject and try finding out the answer. Give me a second. Okay. 1 second. Um. I'll get my calculator and I'll tell you the answer. What is the value we were getting in the previous question? Or can you scroll up? And you can scroll down. Yeah. No, no, not the top. Sorry. Yeah. My answer is coming out to be 2.77 times 10 to the power of negative 24. I think that's wrong.
Times
Neg-
10 to the power 24. So
Negative
you are
24.
negative 24.
Mm.
Okay.
What are you getting?
What's the time in this one? They have given us 9.130. 9.130 exponent minus 7. Okay. Then square root of 2 into the kinetic energy, that is going to be 1.6, sorry, 1.164 10 to the power minus 13 divided by what's the answer that you were getting in the last part? 6.98 exponent minus 6.98 exponent minus 26. So can you calculate this?
6.3 times 10 to the power of 12.
6.3.
3 times
Like
10
the
to the
you're
power
telling
of.
me the overall answer.
Yeah, yeah. Like I just put into the calculator what you worked out and I found the answer. I think that's correct. I'm not wrong.
It's going to be, it should be, it should be 1.67 meter. It should be 1.67 meter.
Yeah, then I'm not getting
It should be
1.67.
1.67 meter.
I'm not getting 1.6. Oh, wait. Sorry, 1 second. I made a mistake. Maybe, yeah, I think it's 1.67. I didn't underroot the denominator. Wait. Uh, 1.67, yeah. Okay. Um, can you show me how you like made D the subject? Like
How you made what?
D the subject?
Basically, I can see this one. Ke is half mv, half mv square, right?
Hmm.
Mv means d over t raised to the power 2. So it's gonna be md square divided by 2t, then kinetic energy. So Ke into 2t is equal to md square. Ke into 2t divided by d square is gonna be m. Sorry, d we have to find out. Yes, yes, yes. So it's going to be m is equal to d square. I'm going to take root on both sides, right? Then I would be getting this one. Got it? Yes.
Okay.
By the way, this is also T square.
Hmm. I'll tell you what
So
I
I would
did.
be
Like,
getting.
I don't know what.
Okay.
I don't know why. Okay, well, I'm getting it wrong, but what I did was k is equals to half m d over t squared, right? And then I took like the half to the other side, so ke times 2, and then I took the m to the other side, so like ke times 2 divided by m, okay? And then I took the square to the other side, which would do under root ke times 2 over m, and then there's t left, right? It's d over t, so I just took the t to the other side, multiplied by t. Like,
Okay.
I can send you a picture if you don't understand.
Okay. Tell, send me.
Yeah, okay. One second, I'll just.
Yes.
Yeah, I was just rewriting it. Good. Just one second. I've sent it now. You can check.
2ke into t divided by m, or yeah, that's correct. Okay.
It is, right? But like, why am I not getting the same answer then? Or am I maybe like calculation mistake or something?
Yeah, it's a calculation mistake. The method is correct. Okay.
Yeah, can you scroll up? I'll just rewrite it one last time. It's coming out. Uh, you know what? Okay, yeah, now I'm getting it correct. I don't know what I did earlier.
Okay, now see this one. The boiling points of some of the group 5 hydrides are shown in figure 1. NH3, PH3, then AFH3. Explain in terms of intermolecular forces why NH3 has a higher boiling point than PH3. So what do you think about the boiling point of ammonia, which is higher than PH3? Yes.
There is hydrogen bonding in ammonia compared, and there's no hydrogen bonding in pH3. So, um, hydrogen bonding is stronger like
Yes, I can
forces.
say that like in ammonia, like the nitrogen of ammonia is going to make hydrogen bond, of course, or like pH3 doesn't have hydrogen bonding or a London force, okay? And hydrogen bond is generally higher than van der Waals force. So it's on 3 marks. So first of all, we have to define which one is going to have hydrogen bonding and which one is going to have van der Waals force, and then we have to define which one is stronger and which one is weaker. So I can say that ammonia, that is NH3, has hydrogen bond, while PH3 has van der Waal force and hydrogen bond and hydrogen bond is stronger than van der Waal force.
Okay.
So that's why to boil ammonia, more energy is required. Explain in terms of IMF why ASH3 has a higher boiling point than PH3. Of course, they both don't have hydrogen bonding, but why the boiling point of ASH3 is higher than the boiling point of PH3?
What? Right.
Yes,
Okay.
they are saying why the boiling point of ASH3 is higher than PH3, and both in both molecule there is no hydrogen bonding. There is only van der Waal force.
Um, maybe like one is pH3 like a giant covalent structure or something?
Um PH3 is a simple molecular structure, and
With how?
also ASH3 is
Okay.
a simple molecular structure.
Right. Right. Um, not
If you
exactly sure.
remember, we
Yeah.
like we were discussing the factors on which IMF depends. So there are two factors that we're gonna discuss. The first factor is the number of electron, and another factor is the surface area. More number of electron means more van der Waal force, strong van der Waal force, and less number of electron means weak van der Waal force. And then again, same goes with the surface area. If the surface area is higher, so the van der Waal force is higher. And if the surface area is lower, so the van der Waal force is lower. So I can say that if you can see the periodic table, so the electron number of astatine, sorry, electron number of AS, okay, electron number of AS, that is going to be larger than the phosphorus. Phosphorus is only 15. Phosphorus is 15. So when the electron number is higher, so means that there would be stronger van der Waal force. So means that I can say the boiling point would be higher. So PaSH3 has more electrons. ASH3 has more electrons than PH3. So ASH3 has a stronger van der Waals force of attraction. Okay.
Okay. Also, sir, in
Now,
the previous part, right? 1 second. Could you go up 2.1? Yeah. Here I was like why did you say van der Waal forces instead of like maybe temporary dipole forces or something like a permanent dipole forces like the temporary dipole forces are van der Waal
yeah,
forces,
exactly.
right?
Yeah, exactly. Temporary
So
dipole, van der Waal force, London force, dispersion force, ID force.
yeah, so why didn't you like how do you know if one thing is like van der Waal forces or if one is permanent dipole forces? How would you know
Yeah,
that?
so yes, basically, the electronegativities of phosphorus and hydrogen are similar. Like I can say that if there would be any group 7 element halogens, So there would be a greater difference in the electronegativity. So there would be stronger partial positive and partial negative charge. Due to that, I can say the compound is polar. And generally, for the polar compound, we are supposed to say they are going to have permanent dipole. And for a non-polar molecule, we are supposed to say they are going to have temporary dipole, that is van der Waals force. So
Right. So
PH3 is a kind of non-polar. PH3, phosphorus hydride.
okay. All right. And what's the electronegativity? Okay, right, right. Okay, never mind. Okay.
Okay, see this one? It's of 2 marks. Draw a diagram to show the shape of the ASH3 molecule. Include any lone pair of electrons that influence the shape. The electronegativities of AS and H are almost equal. With reference to your diagram, explain why the ASH3 molecule is polar. Of course, due to its unsymmetrical structure. This is also the factor. This is also the factor. Like if you can discuss carbon dioxide, if you can discuss BCl3, boron chloride, trichloride. So when we will be drawing the structure for CO2, it's a linear structure. So we have two oxygen atoms on the left and on the right hand side. They are going to cancel each other. Overall, the molecule is non-polar. When they are saying that that's going to be polar molecule, so means that the dipoles are not going to cancel each other. Understood. It's 100% true. Like the dipoles are not going to cancel each other. So can you tell me the group number for AS?
Um, group number. So acetine, yeah.
It's not astatine.
AS, right?
Astatine is
Arsenic,
80.
arsenic, sorry. Arsenic is group 5.
Group 5 means it has 5 electrons. One, 2, 3, 4, 5. It means that this is H, H, H. So we have this one and this one and this one. It has one lone pair of electrons. So also I can say that AS, then I have one lone pair of electron like that. And then I'm going to have, this is the first hydrogen, the second hydrogen, and the third hydrogen. So as you can see, due to the presence of lone pair, due to the presence of lone pair, the shape is pyramidal shape because it is going to have three bond pairs and one lone pair. Three bond pair and one lone pair. So the shape is pyramidal. So the shape is pyramidal and the bond angle is going to be 107 degrees. 107 degrees. Basically, what it does, this lone pair of electron is going to have a repulsion between the lone pair and a bond pair of electrons. So this molecule will arrange its shape in such a way that there would be minimum repulsion and maximum attraction. That's why there is a large contribution of the presence of a lone pair of electron in the molecule to predict the shape of each and every molecule. When there would be no lone pair of electrons, so the shape would be different. And when there would be a lone pair of electrons, so the shape would be different. So we can say this. So if there would be no any lone pair of electron, like I can say, I can give you an example, aluminium chloride. Aluminium chloride means that it has only three bond pairs and zero lone pairs. So means that this is going to be non-polar because this is a symmetrical structure. So why this compound becomes unsymmetrical? It's only due to the presence of lone pair of electron. Okay.
Okay.
Yes. The equation shows the reaction of one ASH3 molecule with one H positive ion. State the type of bond formed between the ASH3 molecule and the H plus ion. State how the bond is formed and the type of bond, and then how the bond is being formed. So what's the type of bond?
Um, type of bond. Just like a coordinate dative coordinate covalent bond.
Exactly. Yeah, exactly. It's called dative covalent bond, right? It's called dative covalent bond.
Yeah. And the bond is formed by the hydrogen donating a pair of electron to the ASH3 molecule.
Basically, this ASH3 is donating a lone pair of electron to this H positive ion, and it would be forming a dative bond like that, which is represented by an arrow,
I don't think
right?
so.
Sorry?
So I have to draw it.
No,
Do
no,
I have
no.
to
I'm
draw
telling
it
you
like
this.
that, or like do I write
No,
it? Oh, okay, okay.
I'm telling you this one, right? So I can say that lone pair of like lone pair of what is this AS? Arsenic, I think so. Lone pair
Yeah,
of
arsenic.
AS is donated to H positive ion to form dative covalent bond. So lone pair of electron is donated to H positive ion. We can write this. And then what about this balancing equation? Oh, okay. Balance the metals first, balance the non-metals then, balance the oxygen then, and then balance the hydrogen. These are the rules. Metals, then non-metals, then oxygen, then hydrogen. There is no metal in this yeah, there is a metal. Sodium is a metal. Sodium is balanced. Then we have to see the non-metal, that is phosphorus. P4. P4. So I'm supposed to write in the product side 3 because it's gonna be 3 and then 1. 4p. It's a P4. 4p. 4p. Equal phosphorus is balanced. Then we have to balance the oxygen because sodium is already balanced. But when you have written 3, Na is unbalanced. So I'm going to write 3 over there. So when I would be writing 3 over there, so then I have to see how many hydrogen and oxygen I have. 3 oxygen or then 1 oxygen, 4. And then I can say over there 3, 2, 6 oxygen. So what can I do for this one? How many oxygen do I need more to balance? It may be 6. So I can say I need 3 more. So 3 plus 3 is equal to 6. Hydrogen, like oxygen is balanced. Now we have to balance hydrogen. So 3 2s are 6. And this is going to be 3, 9 hydrogens on the product side. Then we have 3 2s are 6. Then we have 3 1s are 3. 6 plus 3, 9. Okay, this is already balanced. So this is your balanced chemical equation. When we will be applying the rules, so it would be taking less time to balance. So what are the rules? Balance the metals, then balance the non-metals, then balance oxygen, then balance hydrogen.
Okay.
Write an equation including state sample for the reaction for which the energy change is the standard enthalpy change of formation of nitric acid. Like you have to write down the equation in which you are going to form nitric acid and what is standard enthalpy change of formation when 1 mole of a compound is formed from its elements in their standard states under standard condition. So I can say that I need to form HNO3. That is going to be liquid. They have given you the state sample. So I need to write hydrogen, then nitrogen, then oxygen.
Okay. Got it.
Okay.
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 All right.
Okay. Then see this one.
I don't know why it's zero, but oh yeah, you told me. You told me 1 second. Because any diatomic molecules are always zero, right?
Yes, it's an element. It's an element. That's why all the elements are going to have zero enthalpy change. It's an element, that's why. Okay.
It's not because it's like diatomic or something? I thought you said that. Okay, right. Okay, because it's an element. Okay.
Okay,
Alright.
so it's a 3 marks. Okay. Yeah. So they are saying use the standard enthalpy of formation, calculate enthalpy of formation of nitric acid. So what's the formula for the formation? Because we have two formulae for the formation and for the combustion. For the formation, I can say product minus reactant. For the combustion, I can say reactant minus product. So you can directly
Okay.
apply the formula.
Alright. Um. So product minus react. No, wait. Reactant minus product, right? Yeah.
This is formation, product minus reactant.
Oh, okay. So the product is HNO3. That's what we need to find. Okay. So 2H2O. Wait 1 second. I'll calculate it.
Uh-huh. Delta
And
H is equal to sum of
and
all the enthalpy changes of product minus reactant.
product minus reactant. Wait, so
So product is
product minus
HNO3, that is.
reactant
Oh, we
equals
have to
negative.
calculate this one, 4x.
The x is negative 690 if I'm not wrong.
2
Negative 690.
multiplied by negative 286 plus 4 multiplied by 34. Then this is going to be like that. Then x gonna be, what's the answer for x? What are you saying?
I got negative 690, but I don't know. Wait, I'll check what you did. Oh, one negative 172.5. Yeah, yeah, negative 172.5. I didn't divide my answer by 4. I forgot that. I shouldn't have made that mistake. But yeah, same answer.
Okay, so the answer is negative 172.5, right?
Yep.
Kilojoules per mole. Give the oxidation state of nitrogen in nitric acid. Okay, so it's going to be,
Um, of oxygen in nitric acid.
it's
One
plus 5.
second. Okay. Yeah, I can just calculate that, right? So, okay. Uh,
Involves the oxidation of nitrogen. So, like in this equation, what do you think nitrogen is going to oxidize? From where to where?
oxidize. From I think the NO2.
NO2 is +4, right? Isn't it?
I think,
And
but
here plus
it'll
5.
go from like the oxygen from NO2 would go to, yeah, so it's gaining, right?
Yeah,
+5.
it's losing electron.
Losing electron, gaining the oxidation number.
Yeah, gaining the charge, I can say. So nitrogen, that is going to be N. Nitrogen goes from +4 to +5. That's why they are saying that oxidation of nitrogen. So it loses one electron.
Okay.
When calculate the amount in moles of sodium chlorate, okay, so they have given you the mass that is 4.33. It's very easy question. We have to divide it through the MR and then we would be getting the answer. That's why this is a 1 mark.
Yeah. Right.
So
Okay.
4.33, what's the MR?
Your screen sharing stopped.
Yes, I'm sharing it again.
Sodium chlorate is Na, so 23, 23 plus 35.5 plus 16. 23 plus 35.5 plus 16. That's going to be 74.5. So 74.5. 4.33 divided by
So it's
74.5.
gonna be
0.058.
0.0582. Calculate the volume in dm cube of chlorine produced at this one and this one and this one when you will be using PV is equal to nRT. So it's mean that you will be getting the answer in meter cube, but they are asking the answer in decimeter cube. So then after all, then you have to convert the meter cube into the decimeter cube.
Um. Okay. I know how to like solve this one, but the confusion here is that from meter cube to like meter cube to decimeter cube, what would the conversion be?
Centimeter cube to dm cube to dm cube to meter cube. What you have to do, you have to divide it by 1,000, then you have to divide it by 1,000 when you are going this one. So of course vice versa, you have to multiply by 1,000 when you are going from dm cube to cm cube, so you have to multiply by 1,000. That's the unit conversion.
All right, got it. Okay. Okay, so I'll solve this one real quick. Okay, wait 1 second. So PV equals to nRT. Um, Pressure is 100 kilopascal. So 100 times 1,000, and then um, times volume. 30 plus 273 would be um in Kelvin, right?
Yes.
Okay.
30 plus 273.
And then my answer that I'm gonna get, I'm gonna multiply it by 1,000 once. So 1.46.
dm cube.
Yeah, yeah.
Okay. So directly you have divided by 1000. Okay, the same thing.
Yeah.
Calculate the volume in centimeter cube of 2.5 mole per dm cube hydrochloric acid needed to react exactly with this one. Give your answer to three significant figures.
No, wait, sir. 1 second. Yeah, in the previous question, yeah, if you like multiplied by 1,000 in the denominator, how you wrote, you're gonna get 1.46 times 10 to the power of negative 6.
So the answer would be in, yeah, the same thing.
No, no, like, would you multiply it in the denominator or would you multiply it after getting the answer by 1,000? Because
Oh,
those
yeah, yeah,
both
yeah,
are
yeah.
giving
Yes,
me
yes, yes,
different.
yes, 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 yes. So
Or you can
dm
just write
cube
like the
means
times
that
1,000
you're
after
supposed
the
to.
fraction.
Yeah, exactly. Yeah.
Yeah, after.
Yes.
Okay.
Okay. Okay. They are asking the volume in centimeter cube of 2.5. Okay, 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 okay. Needed to react exactly with 4.33 gram of. 4.33 gram means they have given you the mass in the previous question as well. That's going to be this. Sodium chlorate is NaClO. What they are asking, calculate the volume in cm cube of hydrochloric acid needed to react exactly with sodium chlorate. Give your answer to three significant figures. So we did do the moles of sodium chlorate that were 0.058. And then of course we have to take the mole ratio between sodium chlorate and HCl, that is going to be 1:2. So we would be getting the moles of HCl. After getting the moles of HCl, concentration is given to you. You can apply the formula, mole is equal to concentration times volume. So we can calculate the volume very easily. Okay.
Okay. Got it.
They're asking the volume in centimeter cube, right? So the
Hmm.
answer that you will be getting, your answer would be in decimeter cube. Then you have to convert it into centimeter cube.
Okay. Uh, Wait, sir. First we are going to 0.058 times 2, right? That's gonna give us x, which is 0.116. So
Yes.
0.116 is mole of HCl, and 0.116 divided by 2.5 is going to give you 0.046. So is that the volume? No, wait, that's going to be in
Funny.
dm cube, what I found. So you have to convert that into centimeter cube.
Yes, centimeter cube. I need. The
So
mole is 0.116, right?
yeah,
So
I'm
what
gonna
would be the
multiply
volume?
this by 1000. The volume I'm getting is 0.046, and then when you convert it, you're gonna get 46.4. Just check if this answer is correct though. I'm getting 46.4.
Yes.
Final answer.
Yeah. Okay.
Alright.
Calculate the percentage atom economy for the formation of sodium chloride in this reaction. What's the formula for the atom economy? The thing that you're going to calculate, the atom economy is going to be in numerator divided by the total mass of a reactant, which would be in denominator. Then you will be getting your percentage atom economy, of course, going to be multiplied by 100. So I can say that mass of NaCl divided by the total mass of reactant times 100. Mass of NaCl is 58.5 divided by the mass of a reactant. Reactant is this one. What would be the total MR?
Of total amount of what?
Reactant side.
Reactant. NaClO is 74.5, and HCl would be 1 plus 35.5, so that's 36.5. 74.5 plus 36.5 would be 111.
You have to multiply this by 2 as well
Why? Oh, 2 HCl,
because
that's
we
why.
need total. Yeah, this is 2 HCl.
2 HCl. So 36.5 will be times 2, right? So that's going to give you 147.5. Okay.
What's the answer?
Yeah, that's what I'm doing. 30, 39.6, 39.7, 39.7%.
Yeah. Okay. Okay. 39.7% is the atom economy. Yep.